Yes, so good afternoon, everyone. As I was saying, we're gonna be basically covering three chapters. The first is problem solving and program design. You should know we already covered spreadsheet, database, word processing, web page design. So we're gonna start with problem solving and program design. There is six chapters for that part there. And then we have program implementation. That one has five chapters. And then lastly, programming with Pascal. That one has three there. So for this first section here, problem solving and program design, what we're basically doing here is trying to understand what is the basics of programming. Why do a person create a program? How does a person create a program? And how to basically properly plan to create a program. So it's not just that you have this great idea one day that you want to create a program to solve some sort of problem. Say, for example, it doesn't have to be a complicated program like Microsoft Word, Microsoft Excel. It could be a simple program. Maybe you want to create a program to do some calculation. Um, you're tired of maths. Every minute you have to pull out a calculator to study in maths. So, say for instance, you want to develop a program that would help you to calculate when you're doing trigonometry, when you're doing statistics, when you're doing all of those hard topics in maths. Let's say, for instance, that case there. So you want to develop a program for that. How do you go about doing it? Do you just um, pick a program language, for example, Pascal, C++, Python? Do you just pick a language and start typing the codes and create the program? Or are there stuff before that? That's what we're basically going to be looking at. That there are, in fact, steps when it comes to creating a program. And we're going to be learning about what are those steps, basically. So, we're going to be starting with problem solving and program design, introduction to problem solving. The time is 12:29. We're gonna take 5-minute break at every half an hour. So just remind me at 1 o'clock to give you guys a 5-minute break. It's a lot of information. It's a lot of technical information. And if at any point in time you don't understand anything, please let me know so we can go back over. But yeah, it's a lot of technical information. So let me know where you need further explanation on. I'm gonna try to simplify everything as much as possible. So we're starting with chapter 9.1, Introduction to Problem Solving. This chapter here is basically about, as the name indicates, coming up with the problem. What is the problem that you want to solve? So you have a problem and you want to solve this problem. So that's the first step. Basically, when you want to accomplish something, it doesn't only have to be a program. If you think about it, when you want to do something, say for example, completing an assignment. Say for example, let me think of an example. Give me a second. All right, good. Here's the example. Your teacher gave you assignment. I gave you an assignment. And I gave you back your marks for this assignment. And the assignment went out of 20. And say, for instance, you got 10 out of 20 for this assignment. And the first thing you guys might ask is, what can I do to get a better grade in this assignment, to get higher than 10 out of 20? Now, I say, yes, you can get a higher grade. Now, what's the next question you are going to ask me?
How?
How? So elaborate. How and what?
What to do? What you gotta do to get a higher grade?
But what do you have to do? So that there is a problem. Your 10 out of 20 is your problem. That's your issue that you have there. What do you want to do with that 10 out of 20? You want to solve that problem. You want to get a higher grade. So the question now you're going to ask is how? How do I get this higher grade? What do I have to do? So that's basically what you're doing here. You're trying to understand what is the problem. You're trying to see why is it I got 10 out of 20 and I didn't get full marks. So anything you're doing in life, you're basically doing problem solving. You're trying to find out why this situation happened and basically what could have been done to change the outcome. Could I have added a content page and get a 1 mark more for it? Could I have added an introduction and get another mark? Could I have added a bibliography and get another mark? So all of that is basically, in a nutshell, what problem solving is about. It's not only about programming. Throughout life, whenever you have a problem, we naturally think of things in that order. We try to say, I got 10 out of 20, that's my problem, that's my issue. But why? You're trying to understand now. Why did I get 10 out of 20? And then after why, you try to figure out how can I fix this problem. And that's basically what you do for a program also. You think about what is the problem. The problem is I don't like maths. I'm failing at maths. I don't know how to calculate. And I want to develop a program now to solve that, to basically function as a calculator. And it's basically the same steps. You can consider what's the problem, why is it affecting me, why is it bothering me, what can I do to basically fix this problem. You guys getting the idea? Sounds like a no?
Yes, sir.
Shania, Hadia?
Yes, sir.
Yes, sir.
Okay. Hope that's the case to the rest of you. Alright, so let's get into it. So hopefully you guys have a better understanding. So the first paragraph, let's have Abdur, you can start to read it.
From software.
Yeah.
Software is the name given to computer programs that tell or instruct the hardware how to work. Software, therefore, includes computer programs that create system and application software. Each program exists because a problem first existed and a solution was needed to solve that problem.
Great. So you guys should remember this from third form. Software. It's a component of your computer. Your computer has, anybody remembers how many components a computer has? This is something you need to remember for CSEC.
5?
Yes, 5 components. Anybody remember the 5?
Input, output, processing. Wait, I think I wrote, no. Hold on, never
Yeah.
mind.
You're heading in the
Input
right
and
direction.
output.
Yeah. Processing, you have to add something more to it. But it's basically processing, but a little more to it.
CPU?
Yeah, it's the CPU. Good.
Can't remember the rest right now.
Nobody can help her. The rest of you just silence.
Sir, user is no one?
What was that, Shaniza?
User? The user is one?
No, that's something that is the component of an information system.
Oh.
That's something else. Your answer is correct, but that's just something else. But we're talking about what makes up a computer. So input devices, output devices, the CPU, those are three things that make up a computer. Storage, very good. And RAM. So RAM has a general name. There's another name we're gonna use. Memory.
Sorry, memory.
Yes, memory. So those are the 5 components. If we go back to foundation, basic computer components. So the 5 components of a computer: the central processing unit, input devices, output devices, memory, and storage media. Those are the 5 categories of hardware that makes up a computer, basically physical parts of a computer. So software, one of those categories, this is what Shaniza was talking about. I think I asked the wrong question, but you guys got the idea. The question I confused the categories of the information system and the categories of hardware. So sorry about that, but you guys got the idea. So software, hardware, users, and processing, and people, and all of those things, they make up a computer system. They make up an information system. But that's just technical knowledge. Software now. So going back to the components of a computer, the 2 main components is hardware and software. So we just looked at the categories of hardware: the CPU, input, output, memory, and storage. Now, you can have all the best hardware. You can have the fanciest keyboard, the fanciest CPU, the latest CPU, the fastest CPU. But if you do not have software, your hardware will not work. If you do not have software, your hardware will not work. Why is that? Because your software is what tells the hardware how to work. So your mouse, your keyboard, your monitor, all of those are hardware. But if software does not tell it how to function, does not tell it how to work, then it's just paperweight, basically. It will not be able to do anything. So that's how important creating software is. Now, software is basically a term for computer programs. So the computer programs that run your computer, and there are 2 types of software. There is system software, and there is application software. Anybody remember what is a system software?
So you're talking about the operating system?
Right. So the system software is the operating system that basically runs on a computer. What are some examples? What are some examples? Chelsea, what are some examples of operating systems? Or anyone?
Sir, Mac,
A little more. Almost there. Mac something.
Mac
Mac something.
OS.
Mac OS. Mac is the name of the company. But you gotta say OS or OS X in order to have the name of the operating system. So you gotta be careful with that. It's the same for when you say Chrome. Chrome, no, for example, when you say Google, Google is not the name of a software. Google is the name of the company. You gotta say Google Chrome. So those are some things you guys gotta be careful of, because sometimes in your paper too, they might ask you to name certain applications that you can use. So you gotta be careful to give the complete name. So Mac OS, Windows, Microsoft Windows 10, Windows 11, Windows 8.1, Windows 8. Those are all examples of system software, examples of operating systems. Anybody remember what is an application software? Sahid?
That was a question.
An example of an application. What is an application software? Or you can give an example.
Actually, I guess application software is like the software that allows you to accomplish your goal or purpose. Something like that.
Something like that. Anybody want to help him?
Application software is an app? I don't know.
It could be an app. It's Shanice said if it's like Word, yes, it's like Word. So Word is an example. Microsoft Word, Microsoft Excel, applications, the camera app on your phone, the gallery app on your phone. Those are all application software. So the system software, as the word indicates, system, runs the entire system, runs the entire device, the phone, the computer, whatever the case may be. The application software, as the name indicates, it's for an application. It's for a specific use. So for example, a word processor, Microsoft Word, it's for processing words. Microsoft Excel is for creating spreadsheets. Google Chrome, it's only for browsing the internet. Need for Speed No Limit, as a game. So those software were only developed for those specific tasks: playing game, editing a document, whatever the case may be.
So Google Chrome is both an operating and application software?
No.
But you just said Google Chrome is an
No.
application.
It's an application software, but it's not a system software.
Okay.
I was just explaining that when you're given names, you need to ensure you give the full name. But I didn't mean that Google Chrome is an operating system. Google Chrome is going to be the application software, and Chrome OS is going to be the operating system. See the difference there? So
Yes, sir.
that's why you got to be careful with names. Google Chrome is the application software. That's what you're seeing right now at the bottom of the screen. And Chrome OS is the operating system that runs on Chromebooks. Alright, good. So we have an understanding of what is a software. It is instructions. Software is basically instructions telling the hardware how to function. So the system software tells the entire system how to function, and application software tells certain parts what to do. So it might tell your keyboard that when you press a letter, this would happen and things like that. Alright, so the next paragraph, our next topic is solving a problem. Akila, you could read for us.
You should first develop an algorithm to solve the problem. An algorithm is a sequence of precious instructions which results in a solution. If your algorithm is vague and has conflicting logic, you will not get the correct answer. Problem solving is usually broken into two phases.
Great.
Algorithm phase. Okay.
Thank you. So we're going to take it piece by piece. We're not going to rush through. So remember we started off with if you're going to develop a program, if you're going to develop some sort of solution, think of solution. Think of the word solution. The word solution. If you're going to develop a program, that's like if you're creating a solution to the problem. So, in order to get to this solution, you have to figure out what is your problem. You have to understand the problem. Because if you don't fully understand what is the problem, then you won't be able to have an effective solution. Yes, you can have a solution, but it might not be as effective as it can be if you do not fully understand what's causing your problem. So, the first step to understand or solve your problem is to develop an algorithm. A very important term that you should remember. What is an algorithm? It is basically a sequence of precise instructions which results in a solution. That is an algorithm. Or you can say a series of steps. Steps are instructions. So an algorithm is a sequence of precise steps or instructions which results in a solution. All right. I just remembered an example I used to use. Listen to this example here. Now, you're at home. All of you are at home right now. You're hungry. There's no food in the house. And you want something to eat. Now, your grandmother doesn't live too far from you. And you know that if you go by your grandmother, she's going to make something for you to eat. She's going to make a sandwich for you to eat. So, alright, forget about the grandmother. We're going too far for now. You're at home, you're hungry, and there's ingredients at home. Now, what's the problem? In this scenario here, what's the problem?
I'm hungry.
You're hungry. Very good. So the problem right now is that you're hungry. What would the solution be?
To get up and eat something.
To get up and eat something. Now, say for instance, there's only ingredients in your home. There is no final food product. What would be the solution?
Make something to eat.
Make something to eat. It's that simple. So, the problem is that you're hungry. What is the solution? Make something to eat. So say for instance, you want to make a sandwich. You want to make a sausage sandwich. That's what you feel like eating. So your algorithm Remember, we're trying to solve this problem. Your algorithm is the sequence of precise steps or instructions which results in the solution. So your algorithm, with the example that I just gave you with being hungry and you want a sandwich, is the series of steps you're going to take to make your sandwich. Now, let me try to see if we can understand what exactly is this algorithm. So I'm going to open Paint. Start. So I'm going to open Paint. And when you're developing an algorithm, remember it's a series of steps. So we can number it. So we can say number 1. So 1. What would you guys say would be your first step? If you're gonna make a sandwich, what would be your first step?
Gather the ingredients.
Good. That's very good. Gather your ingredients. What would be the next step? Gather your ingredients. What would you guys do next? Think of it logically. What would you do next? Alright, I'm gonna give you guys a hint. You got the ingredients. You can even say place ingredients on table. Remember, the algorithm is a sequence of precise steps or instructions. So you have to be very clear. If you notice this other part here, if your algorithm is vague and it has conflicting logic, you will not get the correct answer. So when you're developing this algorithm, this series of steps, not only for a program, because if you notice right now, we are developing an algorithm for creating a sandwich. If you're not clear as to what you have to do, then you will not get to the correct answer. You will not get to an effective solution. So, yes, you're gathering ingredients, but where are you gathering the ingredients? Are you going to gather it on the floor? You're going to gather it outside the yard? Where are you gathering it? So, whatever you're doing, you have to be specific. You have to be clear. Because you have to think of it this way also. If you tell your computer or if you tell a robot to gather ingredients, how will it gather the ingredients? Because before this here, you could have added more information. You could have said to gather the ingredients, go to the cupboard, take out the jam, put the jam on the table, go to the table, pick up the bread, and put it in that location. That would be more precise instructions. You guys getting the idea?
Yes, sir.
So step number 3 now. In this case, say this is just an example. So you got the ingredients, you place the ingredients on the table. What would be the next step? Alia, what would you do next? Gather utensils. Good. Very good. So gather utensils. So your plate, your knife, and so on. Good. 4.
Cut up ingredients, like if you got onions and them thing.
Good. Cut up ingredients. What else? After you cut the ingredients, what next?
Take out the pan.
Place in bowl.
What else?
What you said, Shanita?
Oh, I understand. Place it in a bowl.
Okay, good. So you cut up the ingredients, good, and you place it inside of a bowl. What were you saying, Akila?
Take out the pan and then fry it.
Take out pan and then fry ingredients.
Yeah, with
So,
butter.
with butter. So we frying the bread, we frying the that's it. So on.
Ah,
See there.
me ain't even know what we making, sir, so I can't give
We're
you.
making a sandwich. That's our goal, a sandwich.
Oh,
I said that in the beginning.
you didn't say that. I didn't hear that. Okay, we frying the sausage.
Good. So let me see. So that should have been fry sausage with butter. Shania butter or just normal butter? What's next?
Turn off the stove.
Turn off stove. Alright, good. So we can turn off the stove. Did we turn on the stove in the first place? So turn off stove. Place sausage in plate and so on. You guys, all of you get any idea? All of you clear on how an algorithm is developed?
Yes, sir.
Yes, sir.
Adia, Shania,
Yes, sir.
Chelsea, are you there with us? Shaniza?
Yes, sir.
Alright, great. So, so that there is an example of an algorithm. It's a series of precise steps that lead to the solution. And once again, if you're not clear on what are the steps, then you could get to the solution, but you might have problems. That is why some programs, they have bugs inside of them. They have issues inside of them because sometimes the instructions might not be clear. Sometimes they might be missing certain parts that tell it exactly what to do. You going to say something, Shania?
There is 1 o'clock.
1 o'clock? Alright, so you guys want a 5 minutes break?
Yes, sir.
Alright, take a 5 minutes break. You can start back at 1:05. All right, we're at 105. Are you guys there? Akila, Abdur, Chelsea, Hadia.
Yes, sir.
Hi. Hi.
Sahid, Shania, Shaniza.
Yes, sir.
Yes, sir.
So as well
Yes, sir.
hasn't returned.
Are they?
Okay, good. All right. So what have we looked at so far? We looked at what is a software and what are the types of software, and we looked at what is an algorithm. So we looked at those two things so far. The most important thing to remember right now is that an algorithm, the steps are precise. You need to be exact. What exactly will happen? Let me give you guys another example of an algorithm. Say, for example, you want to add two numbers. So you want to add 2 plus 2, and you want to get the answer. So your algorithm is going to be something like insert first number, then it's going to be insert second number, and then it's going to be well, actually before this here you could say record or store number, store that number, and same thing here, you could say store number to be more clear, because you're telling them to insert the number, but what are you going to do with the number? You're going to store the number, and then after you store the number, you can say step 5, add first number and second number, and store result, and then output result. And you can add more precise information, precise steps if it's needed, but that there is like a simple algorithm if you're gonna create a series of steps to add two numbers together. Now, problem solving is usually broken down into two phases. Remember, we're looking at trying to understand the problem. So we have the algorithm phase. We have the algorithm phase, and then we have the implementation phase. So let's see what's the algorithm phase. Chelsea, are you there with us?
Yes, sir.
Alright, can you read the algorithm phase?
In the first phase, there are 5 general steps. 1. Clearly define the problem that you want to solve. 2. Propose solutions and evaluate each one. 3. Select the most reasonable solution. 4. Design an algorithm that is precise and well thought out to solve your problem. Test your algorithm. You must be sure your algorithm works correctly before you can write a program for it.
Great. So, the first stage in understanding your problem is the algorithm phase. The algorithm phase has 5 steps, and those steps are as you can see here. So the first step is to clearly define your problem. Clearly define your problem. So what exactly is my problem? My problem is that I'm hungry. When I get hungry, I get irritated, I get angry, I get frustrated, I just feel like beating up people. That's my problem. You gotta, when you're defining the problem, you have to not only state what is the problem, I am hungry, but add some information to it. Why are you hungry? My parents left me at home, they don't cook nothing, they don't buy no food for me, so I'm hungry. There's no food in the fridge, there's only ingredients. That is why I am hungry. So clearly identify what's the problem. And when you clearly identify what's the problem, you're gonna understand what do I have to do to solve the problem. So that's your first step. Clearly identifying the problem. So you clearly define it. Good afternoon, Fantasia. So our second step.
Good afternoon, sir. Thanks for joining me.
Mhm. Our second step is to propose some solutions. So we're talking about defining a problem that you're hungry. Now, what are some solutions? Can you guys give me some solutions? When you are hungry, what are some solutions that you would come up with?
So you could either make some to eat or go and buy some to eat.
Good. Very good. Anything else? Is there any other solution? Make something or buy something?
Starve?
Starve? That's one too.
Thieve somebody else's food.
Good. So those are all solutions. But starving is not really a solution to the problem. So we got make something to eat, buy something to eat, thieve somebody food, or you can go by your neighbor and tell them that you're hungry and you want something to eat, and hopefully they give you something to eat. Those are all solutions. So after you propose the solutions, like what we just did there, we just proposed our solution. You need to evaluate each one of the solution. What is the advantage? What's the disadvantage? So for example, making your own food. What's the advantage of making your own food? You already have the ingredients in your home. What's the advantage? Your parents bought the ingredients at home. No advantage in making your own food. Would you save money if you make your own food? Yeah,
Save more money, yeah.
yeah, you can save money. If you
It could be healthier.
good, it could be healthier. Good. So if you make your own food, you would save money. It would be healthier. You don't have to worry if anybody will poison you. If you go by a neighbor and you never put anything inside of it, you don't have to worry about that. So those are all advantages. But what's the disadvantage of making your own food?
You might know what you're doing.
Good. That's a good one. You might not know how to cook. So you might burn the food, you might not cook it properly, it might not have enough taste, it might not have enough flavor, you might not like the food. So those are all disadvantages there. Now, that's one solution there, making your own food. What about buying the food now? What's the advantage of buying your own food?
Save time.
Good, very good. And
You don't have to.
yeah, go ahead. You don't have to.
No, the thing like, what was I gonna say? You don't have to do anything. You don't have to cook it. You just
Good.
buy it.
Good. You don't have to exert any energy. You won't waste any time. Those are all advantages there. But the disadvantage could be that you're gonna be spending money. Um, you don't know how the person cooked the food, so it could be unhealthy. Those are all advantages and disadvantages. So whatever solution you come up with, whatever solution you propose, that is what you would try to do. Look at the advantages of each one of them, look at the disadvantages of each one of them, and then you choose, number three, the most reasonable solution. Which is more reasonable? Am I, is the risk of being poisoned or spending money small compared to maybe not being able to cook the food properly so that maybe I could buy the food, or the place where I'm gonna buy the food, they have a reputation of not cooking properly. So I'm worried about how they're cooking food. So in that case, I would go and make my own food. So when you propose a solution, you think of what's the advantages, what's the disadvantages, you evaluate it, see which one you think would be better, which would be more effective, and then you choose the most reasonable solution. Now for that solution now, you're going to develop an algorithm. Now, as we mentioned already, this algorithm is a series of precise steps that would lead to the solution. For Fantasia that just joined, an algorithm is a sequence of precise steps or instructions. So for example, shucks, it goes out that one. So for example, we had this example up here. If you want to add two numbers together, what are the logical steps to add these two numbers together? You might tell somebody insert number 1 and then record that number. Then you might say insert the second number and then store that number. And then you're gonna add those two numbers together, store the result, and then output the result. So it's one logical step after each other. Insert the number, store the number, insert the other number, store that one also, add the two numbers together, and then output the result to get our calculation there. So that is an algorithm. Series of precise steps that are going to be carried out. So, I know I should have saved that image. So, so with the algorithm that we developed earlier, with making the sandwich, that would have been one algorithm we could have done for this solution of making a sandwich there. Now, the fifth step is to test your algorithm. So before you actually go and make any program or make the actual solution, you can test it to see if you can if it's achievable, if it's workable. So in this case here, with making a sandwich, you could instead of frying all the sausage or using all the ingredients, you could maybe use a smaller portion. Maybe fry one piece of the sausage and see if it comes out good, and make a smaller sandwich and see if that will come out good instead of making that large one. So that way you're testing the algorithm to see if it's going to work before you start making anything. So let's see, is there a chapter? Alright, when we get to that stage, let me not confuse you guys. Just understand for now that these are the steps for the algorithm phase. You clearly define the problem, propose a solution, evaluate those solutions, choose the most reasonable solution, design an algorithm, and then test that algorithm to see if it is working. Are you guys clear on all that?
Yes, sir.
Shania and Hadia?
Yes, sir.
Alright. Alright, so remember we said that problem solving has two phases. So we just looked at the first phase, the algorithm phase. Now the last phase is the implementation phase. So what is the implementation phase? Well, in this phase, there are three main steps. The first step is to translate your algorithm into a programming language. Homework for you guys. Let's see. Homework for you guys. List the um, 10 most popular programming languages. So that's homework for you guys. List the 10 most popular programming languages. And it's important that you do because it's good to know what are some examples of programming languages. So, what is a program language? Let me get the definition for that also. Anybody know what's a programming language though? Want to try give it an explanation before we pull up a definition?
Sir, I would assume it's similar to like when we build in a website, it would use like tags and labels.
Good. You're actually correct. It's actually similar to that. HTML is kind of similar to that. So, let's see. A programming language is a vocabulary and set of grammatical rules for instructing a computer. This is for specific tasks. I'm going to be at the bottom here. The formal language comprises of strings that produce strings and machine output. Alright, let me go with this one at the top here. So take this as your definition. Was in blue. A programming language is a vocabulary and a set of grammatical rules for instructing a computer or a computing device to perform specific tasks. Let me know when you guys have that. Y'all finished recording that?
1 second, sir.
Alright.
Finish, sir.
The rest of you finish?
Yes, sir.
Alright. So if you notice with the definition, a programming language, you can think of programming language just like other languages that we have today. Spanish, French, Dutch, Italian. Italian is a language? Yeah. You can think of it as different languages. Now, but think of it that these language are what the computers speak. It's what the computer understands. So if we go back to our um, definition on software, software is the name given to computer programs that tell or instruct the hardware how to work. So remember, the software has to tell the hardware how to work. Now, how does it tell the hardware how to work? It has to speak to the hardware. How does it speak to the hardware? Well, it does that through a programming language. Through some form of programming language. The programming language will contain the instructions inside of it. So in this specific language, it's going to have the instruction to open Paint, close Paint, turn on the computer, shut down the computer. All of that instructions are going to be in this programming language. And this language is going to be translated to the hardware for it to understand it. So a programming language is a set of vocabulary and grammatical rules. So just like how English has a set of vocabulary and grammatical rules, how you're supposed to structure your sentences is the same for a programming language. There's a certain layout, a certain structure that you must put this language into for the system to be able to recognize it as, you can say, words or sentences. As mentioned, it's for instructing a computer or computing device to perform specific tasks. So remember, the software instructs the computer to perform a specific task. So the software is going to be written using a specific programming language. So you can think of it, the software, it could be written in French, it can be written in Spanish, but it will be written in programming languages, and you can see some examples here. We have BASIC, we have C, we have C++, we have COBOL, Java, Fortran, Ada, and Pascal. Those are all examples of programming languages. And Pascal is actually what we will be learning about. It's a very basic programming language that gives you a general understanding as to how programming languages work. Are you guys clear on all that?
Yes, sir.
The rest of you?
Yes, sir.
Yes, sir.
Good. So some examples: Basic, Pascal, C, Visual Basics, and then you guys have this homework here. List the 10 most popular programming languages. So, if we look back at the step, we are translating our algorithm into the programming language. Translator algorithm used in a programming language. So that is why it is important for you to be precise when you're developing your algorithm. Because if in the first place you did not develop your algorithm properly, then you won't develop your programming language properly. Because remember, all you're doing is translating. That's all you're doing. You're translating. You're converting algorithm to the program language. So if in the first place the algorithm was not correct or it was incomplete, then your program language or your program will also be incomplete. So that's why in the first place you need to ensure your algorithm is good and correct. Now the second stage is to execute the code. So you translated the algorithm to the program language here, step 1, and now you need to basically run the program, execute the program code, see if everything is running. If there's any, if you mistype anything or if you have any problems, you run it to make sure everything is working. Now, if everything is working, the third step is to maintain the program. Anybody want to make a guess what maintain the program means?
Sir, like run tests to make sure that it's working properly as intended.
Good, very good. To run some tests on it. And eventually over time, people is like find bugs in programs. Like for example, games and other software, they just find bugs.
Yes, sir.
Right. And then when they find those bugs, they have to go and patch it. That's why they would send out updates. So that is a part of maintaining the program to ensure that it continues to function. So that if any future bugs appear, because when you create it in the first place, sometimes it might run properly. But over time, um, when other persons use it and they try to do something, it might not work and might cause issues. So in those cases, the issues would be related back to the company, and they would basically check it, see what's the issue, and try to fix those issues. That's all a part of maintaining the program. Alright, we're at third one, so you guys can take another 5 minute break from 3 minutes. We start back at 35. If you have any questions, you can ask them now. No questions? Yeah, we're gonna end at 2. Do you want to go longer? I want to finish off this chapter. This seems like we're moving a bit slow. Hopefully we get to finish off this chapter at least. Alright, so what have we covered so far? We looked at what is software. We looked at how do we solve our problem. We developed an algorithm. That algorithm is a series of precise steps. We looked at what are the two phases of problem solving: the algorithm phase and the implementation phase. So we looked at the steps of algorithm phase and the steps in the implementation phase. So now we're basically gonna have like a breakdown of defining the problem. So this is like, this section here is a part of the algorithm phase. Number one, clearly define the problem. So that's what we're gonna be doing here, defining the problem, how we can basically clearly define it. Hadia, can you start the reading for us?
Yes, sir. Do I read number 1 or
Start it from the top.
where do I start? Okay, sir. Defining the problem. When you first analyze the problem, you should specify your objectives, that is, what the program is meant to do. The following 4 steps are used to organize and summarize a program's objectives. 1. Text, numbers, and text, or even graphic? Is this output in readable form, or is it for input to another program? Will it be displayed on a monitor as soft copy, printed, or stored in a file? Sir, go on.
Yeah.
2. Specify the input. If you know what the output is, you can specify what values are needed for the input. Data can be captured by an input device such as a keyboard, transferred from a secondary storage device, or even entered via voice recognition. 3. Specify the processing. What processing should be done on the input to get the necessary output? For example, what calculations are needed? Is the processing grouped as a batch or completed in real time as the data is captured? Most programs also. 4. Specify the storage. Determine how the data and even the information or results will be stored temporarily or for future use.
Great. So, defining the problem. How do you define the problem? How do you try to understand what is the problem? Well, you need to specify your objectives. What are you trying to do? What are you trying to achieve with this this program? So specify your objectives. What are your objectives? 1. Specify what is the output. When you want to create this program, what do you want the output to be? So do you want the output to be numbers? Do you want it to be text, numbers and text? Or do you want it to be a graphic? Do you want it to be an image? Do you want it to be a video? What do you want the output to be? So for example, our calculation here, what do I want my output to be? I want my output to be a number. So just a number will be sufficient. The output, should it be in readable form or should it be going to another program? So should it be soft copy output? Should it be printed output? Should I store the output in a file? Those are all different methods of output to determine how you're going to output the results. Then you have to specify what is your input. How am I getting the data into the program in the first place to get an output? How am I putting this data into the program? So, are you going to use an input device such as a keyboard? Does the person have to type the answers in? Or can it be transferred using a secondary storage device? Or can the person speak Like for example, on your phone, you can use a voice assistant. You can say, "Hey Google, add 2 plus 2," and it's going to give you the result. So the input, how are you going to input the data? Do they have to type in the data? Do they have to speak the data? What are they going to do? And but most importantly, you have to say what is the input. That's important. What are the values that are needed? Is the person supposed to type in their name? Are they supposed to put in numbers? So in my case here, they need to input numbers. They need to input 2 numbers to be exact. 1 number, 2 number. So that is my input here. And then lastly is the processing. What am I doing with this input to get an output? What am I doing with this input to get an output? So what processing should be done on the input to get the necessary output? For example, what calculation is needed? And how will it be calculated? Will it be calculated in batch or will it be calculated in real time? So in my example, once again, what calculation needs to be carried out? I need to add number 1 with number 2. That is my processing. That is my calculation that I need to carry out here. So that is how you define the problem. And then this part here is optional, number 4, because not all programs would store the result. But if yours does, you would have to specify where you are storing the data. So you have to determine how the data or the information or results, if it's going to be stored temporarily or if it's going to be stored permanently. So anyone remembers IPOS? Anyone remembers IPOS?
Yes, sir.
You remember what it stands for?
Yes, sir. Input, processing, output, storage.
Right. Input, processing, output, and storage. So when you're defining the problem, it's basically that IPOS cycle you're determining. You're determining what is the input, 2, what is the processing, 3, what is the output, and then lastly, what is the storage? Am I going to store the data or not? So that there is how you define the problem. Now, lastly, the IPO chart. So that same information there, you would create that information and put it inside of a chart. Let's see, Shania, could you read for us?
Yes, sir. Input, processing, output, IPO charts. IPO charts are used to identify the inputs, the information you need to solve the problem, processing, the steps needed to convert the input data to desired outputs, the goal of the problem solution. An IPO chart is not actually a chart, but a table with 3 columns. Each column represents 3 components: input, output, and processing. The storage component is not usually documented in the chart.
Great. So the IPO chart is basically a continuation of defining the problem. And remember, that's linked back to the algorithm phase. It's all one big continuation of the phase there. So in the algorithm phase, you should define the problem. How do you define the problem? you specify what is the input, what is the output, what is the storage, and what is the processing. Now, how do you document that? You could simply write it. You could simply say input and what is your input, but we have a IPO chart that we can use. And as you just read, the IPO chart is not actually a chart, it's just a table. This is an example of it here. It's just a table. So imagine it like this here. It's a simple table. You have the input column, you have the processing column, and you have the output column. So the same three information you would put into the chart. As it mentioned, the storage component is not usually documented. So in that table or that chart, you're going to put the input that you need, you're going to put the processing, and you're going to put all of the output. So let's look at an example. Example 1. You're given a problem of finding the sum of three numbers. So the problem, you need the sum of three numbers. What is the goal or output? And what input information do you have? The output or goal is a number which is the sum of the three numbers. So what is my output? The sum of three numbers. The input is made up of the values of the three numbers. So input, values of the three numbers. Now, what are the steps needed to convert the input into the output? The processing requires, so this here is the processing. The input of the three numbers, so you put in the three numbers. That's my processing. You put in the three numbers, and you add the three numbers together, and then you save the results as a single number, and then you output the results. So input the three number, add the three numbers, save the results, and then output the results. So notice that the processing column is written in English. The completed IPO chart is shown below. So notice on the input, we have input number 1, input number 1, input number 2, input number 3. Then when we're finished inputting, processing, what's going to happen on the processing? We're going to add the three numbers together. And then output, we are going to output the result of that addition here. So you can follow an IPO chart by reading each column left to right. For example, the input column indicates that you input three values, as you can see here, input number 1, input number 2, input number 3. And in the processing column, you add the values that were input. You add the three numbers together. In the third column, outputs the result of the addition. So in the third column, we have the result of the addition there. Example number 2. You're given the problem of finding the average temperature. So what is our problem? We need the average temperature. We're going to use the maximum and minimum temperature in order to get our calculation. Because that's how you do average. You get the maximum, you get the minimum, or you get all the values and you divide. So you then calculate the output temperature to calculate the average and output the average temperature. So that's our input, processing, and output. So the IPO chart, we have the same chart once again. Input, you put in the maximum temperature, you put in the minimum temperature. Processing, you calculate, you say what is the calculation. So if you notice here, we have the exact calculation. We take the maximum temperature, add it to the minimum temperature, and we divide it by 2. So we have our calculation going on here. And then lastly, we output the average temperature. Are you guys understanding how the IPO chart works?
Yes, sir.
Alright, we have another example. We're gonna read a number at 10%. So this is our input at 10%, that's our processing, and output the results, that's our output here. So, table, input, we're gonna input the number, processing, we do our calculation here, result is gonna equal number plus, remember we're adding 10% to the number. So this part here, we're calculating the 10%. So if you notice, it's just like a normal math equation. We're calculating the 10% in bracket first. Remember, brackets are first. So number multiplied by 0.10, calculate for 10%, and then we add it to number. Now, anybody want to make a guess what this equal sign is doing here and results? This part here. Any guesses? So, what it's actually doing here, Akila?
Never mind, sir. Continue.
So what it's actually doing here, it's adding the numbers together, and then the equal sign basically means to store it inside of results. That's all it means here, to store it inside of results. So if you notice in the output, it's saying output results. That's all it's saying here. Add the numbers together, store it into results, and output results. So whatever is inside of results will get outputs. So whatever the answer will be. The final example, input the regular price of an item. So input the price of an item and calculate the discount of 20% and also the item's discounted price, and then output the discount amount and the discounted price. So our table once again. So we have input, you put in the regular price as it mentions here, and then for processing we have to calculate our discount. So notice discount amount is equal to 0.20, that's the 20%, multiplied by regular price. So that's going to give us our discount amount. And the discount price is going to be regular price minus discount amount. That's going to give us our regular price. So we have two outputs here, discount amount and discount price. Shania, Chelsea, Shaniza, are you guys following?
Yes, sir.
All right.
Yes, sir.
So, if we want to develop an IPO chart, say for example, we want to add two numbers. We want to add 2 plus 2. How are we going to develop our IPO charts? So this is input, this is processing, this is output. What would be on the inputs?
The two numbers, number 1, number 2.
Good. So number 1 and number 2. So that's our input. We're inputting two numbers here. What would be our processing now? What would you put on the processing?
Insert the two numbers.
As that insert two numbers is already input. Remember, processing is calculation. Whenever you hear processing, think of calculation. So what are we doing with these two numbers that we already input in the first column?
Add the two numbers.
Good. Now, one thing to take note of, that's good, that's correct. One thing to note is that, where did it mention it? Here, look at this part here. Notice that the processing column is written in English. Now this IPO chart, there is no standard. You are basically writing it based on how you can understand it. So, for example here, you could simply say 2 plus 2. Or, you can say add 2 plus 2. Or you can say, you could even say add 2 and 2. Because remember, this is not your program that you're developing. It's just a clear explanation as to what exactly will happen. So at first, you can start off writing in English words where you can understand what is happening. And then over time, as you gradually understand everything a little better, that is when persons would write more simplified algorithms, more simplified IPO charts. So that would be the one at the top here. They would say 2 plus 2 equal results. So let's ignore this top here and create another column. Ignore this here. So this is going to be output now. So over here, they would say output results. So that's going to be this here. But you can say, as mentioned, add 2 plus 2, add 2 and 2, or you can even say add num 1 and num 2, and that could be processing. Once it is clear what is happening on the processing. Are you guys following? Alright, so complete these questions for next week. Your homework for next week, additional homework for next week. We're gonna review that next week. So, in conclusion, we're finished with this chapter here. So, what have we learned in this chapter? We learned what is software, how important software is. It controls the hardware. So that's why we create software today, and that's what we are learning about. How to create software, how to create programs. What is the first step? Problem solving, solving a problem. You have to start with the algorithm phase, and the algorithm phase is to clearly define the problem, propose solutions, evaluate each solution, pick the most reasonable solution, design the algorithm, we learn what is the algorithm, and then test your algorithm. Later we're going to learn how do you test your algorithm. But we already looked at how to define your problem. We looked at how to define the problem. That's what we looked at over here. And coming up with solutions, evaluating on it. I gave you guys examples of that. You pick a solution, think of the advantages and disadvantages, and then you choose the most reasonable one. And then you design an algorithm. I showed you guys an example of doing that. And then later on, I'm going to show you guys an example of testing your algorithm. And after you finish your algorithm phase, you move on to implementation, where you translate to a programming language. Remember your homework on that. You execute the program, maintain the program, And further on defining the problem, you can further define your problem by creating your IPO chart. Remember, the IPO chart is not an actual chart, it's just a table with 3 columns. Basically, you indicating specifically, precisely, what is the input, what is the processing, and what is the output. Alright, any questions before we close off?
No, sir.
Alright, so we're gonna end here for today. Enjoy the rest of the day.
Bye, sir.